Hi folks, I just wanted to do a quick teardown of an old multimeter I found in the garage. Here it is. It's an old case. You can see it's all beaten up. I'm not sure if there's anything in here. The zipper looks to be badly damaged. Yeah, it's all just pretty much falling apart, this case. And I'm not sure what vintage this meter is, but this is what it looks like. And it came with these two probes here. So it's a Kaise Electric Works Ltd, made in Japan. You can have a look here with the magnifying glass if you need to see. And what we've got here is DC voltage measurement, ohms. DC voltage ranges from 0.5 volts up to 1,000. The ohms is times 1 up to times 1,000. There's AC voltage measurement from 10 to 1,000. And there's also DC, milliamperage rating from 250 milliamp to down to 100 microamp. So we're going to have a look at those as much as we can. There's not a fresh battery in here, so we might have issues with the amp readings because that requires battery, but the DC ohms, I think the voltage reading should be fine. Let's give it a quick go. I'm going to plug this in. Okay, and I've got another digital multimeter right here to compare to, and I have a battery right here, 1.5 volt battery. So let's start this up. We've got ourselves in the voltage range here. It's auto ranging. Let me get it to get it into the DC. There, that's DC volts. So if we put this across, we should have, if I can balance this correctly, it's a little bit tricky on these little batteries. There, and as you can see there, it says 1.553 volts. So that's what we'd expect from this pretty almost brand new battery. Okay, now we go to this multimeter and I set this up. I should turn this over to the 2.5 DC volt rating, and in that case you should see this needle deflect over. Now you can see on this meter the black part here, I'm not sure how clear it is, but not the red part, but the black line below is DC, and it goes 0, 5, 10, 15, 20, 25. The one below goes 0, 2, 4, 6, 8, 10. So what that means is, if I'm to read this correctly, if I set this to 2.5, it should basically go up to the right measurement. Hang on 1 second. Okay. Give me 1 second. I'm going to adjust the setting on the video here because my screensaver is turning on and I can't see what I'm recording. Okay, here we go. I've set the screensaver off so I can, otherwise the backlight, the LCD display on this SJ cam turns off and I can't see anything that I'm recording. I'm not sure if it's doing it still. Any case, back to the Kaise Electric Works Ltd. If I set this to 2.5, then I theoretically speaking, I believe the range means it goes from 0 to 225. That would be 2.5 volts at the end. So I should get a needle deflection to about 1.5, which is right here. Okay? And we put this on, and we give it a try. Okay, first of all, it's going backwards. I plugged it in backwards. Hang on a second. There we go. And if I hold it just right, our needle deflects, but it's deflecting way too far over. Way too far over. And that's almost near the edge of the 2.5 range. Let's try another one. Maybe it's got issues. So I've got it now to 10. And there's another mark underneath, under DC, that goes 0, 2, 4, 6, 8, 10. So theoretically speaking, it should go somewhere way down here below the 2 mark, somewhere halfway between 1 and 2. So it should be just in that region there. And so I've lined it up, and once again we're getting way too high. You can see it's going up to 2. Okay, when I put that on, it should not go that far over. So something's definitely up with this meter, at least when it's measuring voltages, it's way off. Okay, now I've got also, I don't have an AC source right now, so I'm going to just use the resistance scale and see how that's working out. So I've got a 1 times there, and my resistor starts off 0 ohm here and goes all the way down to there. Now there is a battery in here. There must be one in order to allow resistance measurements, as far as I understand. So, because otherwise there'd be no power source to deflect the needle. So when I short this, you can see it's going all the way up to the 0 mark, and I have an ohms adjust here. So if I play with that, you can see that it moves up and down. So I'm going to place that right there, so it's exactly on the 0. Okay. Okay, so that's with my needle shorted. Okay, right there. It's on 0. And then the scale goes backwards this way. So I have a resistor here somewhere, which I previously measured to be about 460 ohm, and this is the meter here. I'm going to put it to ohm setting, and it's on auto, so let's just put the resistor across here and see what it measures. Okay, it's jumping all over the place, sorry, because I'm not holding it properly. If I hold it just so, it's showing 0.461 kilo ohm, so it's 460 ohm. Okay, and I can turn that off. That means that on this meter, where it says 0, if this is 1 times, then it should go up to about there, which is 500 ohms. If I change it to 100 times, then all these numbers are multiplied by 100, so that 500 there should be 500 times 100, so it should be 50,000. So that should be 50k ohm if I'm on the 100 setting, multiplied by 100. So let's see if it goes to there, because it should go over to the 500 mark. And if it doesn't, most likely the battery in this thing is toast, so it's not able to have enough power to deflect the needle. And yeah, it's barely doing anything, as you can see. It's just not, it's almost reading like it's a complete short through this thing. So let's open it up and have a look inside and see what kind of battery this thing takes, and if there's any hope of me getting it to be functional. Now you can see the back of the case has been beaten up nicely. It's not doing very well here physically. But it still should be functional. Okay, we'll get these screws out. There's 1, 2, 3, and 4. And we're going to slide this out, or does it just drop out? There it goes. Okay. So here we are. Oh, look at that. So there's the inside construction. It uses 2 AA batteries, surprisingly. And you can see old school construction here with the this feels pretty good. I mean, it's quite a nice mechanism as far as the slider here. But yeah, I'm glad to see they're using regular batteries. Remember, I haven't been in this multimeter for 10, 20, 30 years, who knows. And the batteries, surprisingly enough, Radio Shack, are not leaking at all. They're actually quite in good shape. I would have assumed they'd be leaking by now. Okay, you can see this ohm wheel is a little bit off kilter. There's a screw holding it down there, and it looks like it's tilted a bit. So it just needs a little bit of adjustment of that screw and turned, and then it'll line up nice and straight instead of being off at an angle like you see there. All right, so let's just check out of curiosity what the voltage reading is on these. But I mean, obviously it's not we might get a quite high reading. It doesn't mean the batteries have any energy left in them though. And let me make sure that it's DC. Okay. 1.4. Yeah, so that's, I'm not sure if these batteries are, they definitely don't have any juice left in them. That one says 1.4, but just pretty weak, I'm sure. And I don't have any good batteries downstairs, but I'll see if I can get some fresh ones in a moment. Anyway, there's the inside. I'm going to open up this board here, but I don't want to open up anything else. Definitely not the meter segment here. I don't want to mess around with the very fine magnet and coil in there. But let's see what's under here, and if it comes up nicely, just to have a look at the components on the other side of the board. And we'll see if there's any hint of a date on this thing. So I've removed 2 screws there, and I have a feeling that based on the way this is constructed, it's not going to be, I have to remove this nut as well that holds in the wheel. So give me a moment. And we'll see if this will come off easily or not. I'm a little weary of taking this thing apart. Let's see if this will come apart this way. Oh, I think I've done it. Okay. So this is coming off now. Okay. And there's the wheel. It only goes one way. Okay, and this should slip out. There's a spring in here, you can feel it. Yeah, but this board is still well attached in there. And there's even a little adjustment pot I can see through that hole right there. So if I can tease this out somehow carefully, we'll be able to see, oh, something's happening here. If I can just lift it up here in this corner, and we're getting there. I'm not so sure I needed to remove that screw, but I think I did, because it looks like it has to slide out here. Okay, here we are. Okay. So, yeah, and you can see there. So there's not much to it. Wow. Not much to it at all, except you can see that resistor there is completely fried. Yep. Okay, so there's the inside construction. You can see the little ball, and you turn it here. Well, that's come off now, so the ball was underneath there. Now it's just floating around. I can try to put it back in there, but there's a good chance that I'm not really going to bother with this meter too much. First of all, I have to replace this resistor here. It looks like it's completely fried. As you can tell, that one right there is burnt up solidly. So whatever range that was for, you know, it's blown the hell out of that one. The rest of the resistors seem to be in pretty good shape. I see a few diodes in there, but yeah, the construction of this meter is pretty much as simple as you can get. It's really, really, really simple. There's not much to it at all. And let's see here, there's another couple of diodes back to back. and another, looks like a capacitor, and the ohms adjust goes through another resistor there, but it's all old school. I can't seem to find a date code here, unfortunately. There's absolutely nothing indicating when this thing was made. It says there 2 joules, Japan. Not sure what the 2 joules refers to. Perhaps there's some kind of mechanism or the joule that sits on the hinge here that lets the needle deflect very cleanly. It's sort of like the joules in a watch, where you have the sprockets, the gears on the watch have very clean movement because they sit on small joule bearings or sort of pivot points. So that's probably what that indicates there. But yeah, if I wanted to fix this meter, which I don't think is worthwhile, I'd have to figure out exactly what resistance, essentially what resistor went here to replace this fried one. There it is there. And I'd have to solder it in and basically get this thing, the ball, back into there, close it all up, and there you have it. But I don't think it's worth it, for a few reasons. One is I'm gonna have to find out a good replacement that's got accuracy. I'm not even sure what the accuracy on these were, but I'm gonna have to make sure I find one that's accurate. Second of all, there's so many other meters now that work as good or better than this thing. It's really not going to be used for any practical purposes. It's just pretty much a nice looking relic, but that's about it. As far as worthiness, it's pretty much garbage. So, but there you have it. Just to have a look at an old multimeter teardown and try to figure out what happened to it. And it appears that it got into a little bit of trouble, perhaps a wrong reading or wrong setting when it was being tested on some circuit, and it blew the crap out of this resistor, which you can see there is completely charred and blackened. So that's it. Hope you enjoyed this little teardown video, and if you know anything about this Kaise Electric Works brand or any idea of the quality of this thing, please leave it in the comments and let me know if you have one of these, what kind of performance you were getting out of it. Thank you again, and hope you enjoyed this video. Thank you. Okay, just a little quick look at the actual needle mechanism. I managed to pull it out of the meter. I've hooked up an old 9-volt battery here just to try it out, and I've hooked up one side to the one end of the there's a little electromagnetic coil inside there, and when you touch it to here, on the other side of the meter, you can see the needle deflect. Okay, so when you measure voltage, you basically are just running a current through the coil, and because of the magnetism, it deflects it. And when you want to change your range, all you have to do is put a resistor in line with that, and depending on your resistor, you can cut down the voltage that passes through the electromagnets, and then your needle deflects less. So that's essentially the how, in principle, how at least that part of the meter works. Let's see if I can do that with this. So I've got, when I touch this normally without any resistor, you can see there's full deflection. I'm going to try to stick a resistor across here and see if it changes. See, that resistor is not strong enough, so it will tend to go still quite a bit through and still deflect fully. Perhaps not as quickly though. Okay, but that's the essentially how it works. The ohms reading depends mainly on having a current going through and then dividing the current through known resistors as well, and that also will reduce the current through the coil. But you have to have the meter itself supply the power, because you're testing a circuit and you want to see, you know, through low power, of course, you want to test the difference between the voltage through the known source and the unknown source, and that essentially calculates out how much the needle deflects based on what voltage does make it through the meter versus the unknown source, and using essentially a resistor divider type calculation. It's built in, it figures it out. So there you have it, the Kaise Electric Works. Now, I still don't have any date put on this at all. So I'm not sure when this was made. It looks like late 70s. I don't think it was early 80s. There's a 33-10 here. I don't think that's a date code at all. That's probably the model number. Quite a nice little meter. I might keep this portion just to play around with, as it's nice to you know, to have this bit of old style hardware. But the actual meter itself, the rest of it, oh, there's a nice magnet right there. The rest of it looks like a piece of junk, to be honest. You can see it's just a number of resistors. I've bent these down, by the way, but they were up like this. Just a handful, maybe a dozen, less than a dozen resistors, and just to act as the for the dividers and so on, and that's it. So, and really the little ball joint mechanism here, which was very simple to get through the different ranges as well, and then the tab on top that went across here and then completed the circuits through various resistors for the different ranges. So there you have it. That's the teardown. Thank you again. I just wanted to demonstrate some of the movement of the needle here. This is the needle mechanism out of the multimeter, and I hooked it up, as you can see here, through these cables to a small little speaker, just so I could hear things. And it's joined up to this tuner and radio. So I was playing around with the equalizers and the volume, and you can make a small little meter. Now, it's not very responsive. It oscillates quite a bit, and unfortunately it's because it really needs some dampening and the right volume controls and everything. But here's just an example, seeing the needle deflect based on the sound. You can hear there a little bit of the sound. I'm going to talk over it just in case, because I don't want YouTube video to pick up the sound. It's quite distorted out of this little tiny speaker here, but at least I can monitor what's coming out of the phones. Otherwise, I'm not really sure what this is you know, showing. You can see there. Okay, now when I play around with the equalizer on the radio, if I turn up the treble, you can see the meter just goes nuts and the speaker cuts off. You can't handle it. But there's a setting here where I can tune it just right, and you can see it going through pretty much the full range. It's a little bit wild. I put a capacitor on here as well. I'm not sure if you can see it under there, to try to take out the DC from the signal and just have it pass through AC. But in any case, this is not a normal way to create meters on sound. But if you have a few lying around and you want to play around, that's an idea of how to do it. Just coming straight out of a tuner radio. And if I put the magnifying glass here, you can see it going nuts there. Well, right now there's no beat there. As soon as the bass hits, it starts to go crazy. And that's just the amount of energy and the sound signal, the voltage. So anyway, there you have it. Just a quick demonstration of the meter being driven by an audio sound signal, like this little speaker, which you can hear. Hopefully YouTube won't flag the video based on the sound, but that's basically here. I'll turn it down again so you can't hear it. But there you have it. Thanks again for watching.